Good morning, everybody. This is Mr. Bretherick. I'm going to be going through a series of types of attacks dealing with wireless communications, wireless attacks. And as you can see, we have a handful of them down here. The replay, the Ivy attack, evil twin, rogue access points, jamming, WPS, a Wi-Fi protected setup, blue jacking, blue snarfing, blue bugging, RFID, NFC, and disassociation, or some references may have it as disauthentication. So the first one we're going to look at here is the replay attack. Now keep in mind that when you start covering other parts of Sec Plus that you will probably see these types of attacks brought up in other areas other than wireless. Replay is one of those that may be seen and utilized by other than wireless communications. But for a replay tech in a wireless environment, a few things can usually happen. First step is normally there is somebody, an attacker in this case, is going to be there trying to capture or glean information for your wireless users or clients. This is done by capturing that over a Wi-Fi network, so in most cases they can replay it again later, play it back to the original client or back out to the other users. Attacker's going to resubmit those credentials later and be authenticated as that legitimate user. Some of the mitigations that we have for replay attacks is a lot of times we're going to have this as a means of mitigation is using strong encryption. Certain protocols, strong encryptions are going to have this capabilities. Legacy devices may only have a certain capacity. And best case scenario, use those that offer mutual authentication and any randomized session numbers that are generated. Another wireless attack is the IV attack, known as the initialization vector. It is a block of bits that's used to randomize that whole encryption scheme for your wireless devices. Sometimes they may reference these numbers as what they call nunts, or number used once for the values for initialization vector. A lot of times these types of attacks is the fact that they make themselves susceptible because those numbers that they're generating that's utilized once is too small. Small size outputs or capabilities. That, in a lot of cases, dealing with encryption as a whole is going to cause a repetitive nature or repeating the IVs. When you start having a pattern being set, that makes it more susceptible to guessing and types of attack and taking advantage of that. So some of the mitigation here is use wireless encryption, those that offer a larger subset or IV numbers. Those are going to be less likely to start reusing or recycling those values. The evil twin is another wireless attack, and you may also see it in wired environments too, whereas an evil twin is a rogue device in a Wi-Fi environment. In this case, it's a rogue access point. A lot of times you see these may be more susceptible in public or free hotspots or free Wi-Fi areas. Some common examples here are those that we find in hotels, cafes, restaurants, airports, those that allow as a convenience factor your Wi-Fi users to connect. Evil twins a lot of times will stand out in the sense that they're going to look identical to something that's supposed to be legitimate as an access point. The attacker a lot of times will put those devices in place to eavesdrop, gather intel, in most cases trying to collect other users, the wireless users, their credentials. That is, if they do not have any sort of protection scheme associated with their devices. Some mitigation tips here is, well, for one, avoid the free Wi-Fi areas. Making sure users are aware of the fact if they are using the free Wi-Fi areas, that is a possibility. Avoid promiscuous Wi-Fi connections. Disable or harden those features by disabling the auto connect. Change and or disable the SSID, and use strong authentication. And best case scenario, once again, is mutual authentication. Rogue access points, something very similar we were talking about before for Evil Twin. Rogue devices are really nothing more than devices that are not supposed to be there. They're unauthorized. Unauthorized wireless access points. Sometimes they could be added by mistake or maybe users being complacent. But in most cases here, since we're dealing with attacks, those are done for malicious reasons, trying to gather information or maybe create some sort of denial service or a distributed denial service. They may also try to take advantage of stealing identity of the physical addresses of those devices. For those environments that are using some sort of means of dynamically assigning IPs, sometimes these are put in place as a means to try to do a scan of those wireless devices. A lot of these attacks will introduce some sort of level of that first step or first stage. This is that man in the middle. They can be used this as a set point to gather information, gather intel for all the users in this Wi-Fi environment. So some of our mitigation tips here are using sensors. Sensors in place in not just wired environments, but also wireless. Utilizing intrusion prevention systems. Specifically for wireless, they're called WIPs, Wireless Intrusion Prevention Systems. They will detect and dismantle or try to stop those means of rogue devices trying to connect and gather intel. Being proactive administratively, if you're a single user, you're sort of acting as your own administrator. Be proactive and do scans of your networks. Make those discoveries. Know what wireless devices you have within your network. Anything that's not supposed to be there, being a rogue, you probably want to disable those. Jamming is another form of wireless attacks. Jamming can be done in different ways. For the attack version here, they're there to stop or disrupt some sort of means of wireless connections. Sometimes that can be done by introducing interference, generating noise, or some sort of a collision at that receiving point, which does not allow your user to connect. Sometimes they will basically be there to overload any type of network utilization. So if you find some sort of means of jamming, it could be non-malicious in nature. Some things that you could do is change the frequency. Like I said, this could be done in a non-malicious fashion. A lot of devices are going to be connected wirelessly nowadays, so sometimes you may have different wireless devices on the same network, causing some sort of denial of service, if you would. So mitigations here is to upgrade to newer wireless LAN environments, commercial off-the-shelf types of software that's going to be there to prevent jamming types of attempts, scanning for culprits, being aware of your networks, knowing what devices are supposed to be there, having some sort of blockage so you don't have some sort of interference for your wireless devices. And once again, if you're using these frequencies, it may be possible to maybe change those frequencies. WPS is another means of wireless connectivity. They were created as a convenience factor for users that may not have a very good or strong familiarity with Wi-Fi connections. It allows users to connect to a wireless environment by two different ways: entering a 8-digit PIN or by physically pressing a button. I say physically, sometimes they have apps that have associated that too. Both are going to be considered insecure, which is one of the mitigations, is to disable WPS on all those devices. But a lot of times it's going to be more susceptible by doing with a PIN, because really the users are going to be having to associate that PIN that's in most cases also going to be located on the device. A lot of times what makes it weak for the 8-digit PIN is the fact that that is just way too small. It's easy to guess within hours, because we have attack software that will go through all possible combinations to try to guess or simulate those pins getting access. And when they do, the attackers do that, they can actually now introduce some sort of brute force attack on those devices using WPS. So once again, mitigation for WPS is disable WPS on all those devices. Bluejacking is another form of wireless attacks with a lot of your devices that have Bluetooth enabled services. There's a handful of these types of attacks that take advantage of Bluetooth services that we have on our devices. Bluejacking is one where it's going to be more or less a nuisance. Less severe the ones we're going to look at here shortly. Bluejacking is going to be sending unsolicited text messages or SMS-based messages. Sometimes they could be images or sound bits That's to any device that has or utilizes Bluetooth services, mobile phones, tablets, PDAs, laptops. This is a form of what they call doorbell ditching. We've actually probably did this as kids. It's like a prank. Run up to somebody's door, ring the doorbell, run and hide, and wait for them to come out and look at them totally confused. This is a sort of kind of like a technological version of that. It's usually harmless, but sometimes the users may think their device is malfunctioning. So as a mitigation here, disable those Bluetooth features altogether or only when you need it. Another form of Bluetooth services type of attack is called BlueSnarfing. It's unauthorized access or theft of information through wireless devices using that Bluetooth connection. With BlueSnarfing, those malicious users are now going to be able to start getting into certain areas that you may not want to, like your emails or previously sent text, your contacts. They usually get this information to try to take in, or sometimes portray the actual user themselves. Those attackers will synchronize those devices using Bluetooth services to try to gain access with the information. This is sort of kind of like the next stage, as we were looking at before. So once again, mitigation here is turn off Bluetooth features on those devices that has that as an option. Of the Bluetooth types of attacks we see here, bluebugging is the more severe of the three we're mentioning here. These types of attacks take advantage of Bluetooth services are going to enable certain features on all those devices just to get unauthorized access and take control. So in the process, they could have those first two levels of Bluetooth attacks, but here they're actually trying to take over as that user using the Bluetooth services. They can install backdoors, make phone calls as the user, send messages, text message or SMS messages. They can enable any other services like tracking features on the device so they can actually see all the progress or where the person goes as long as they have the device with them. Modify any other security settings, making it more vulnerable to other types of attacks. So mitigation here is disable all those Bluetooth features until needed. Also monitor for any suspicious activities on those devices. Restarts, disconnecting, reconnecting intermittently, increase of data usage. You want to be cognizant, not complacent here. You want to be aware. Also, another thing that could be done as a mitigation is to help remove these backdoors or any malware that may be installed is do a factory reset. Those in most cases will reset everything back and get rid of those types of malware and backdoors. RFID, radio frequency identification. This form of wireless attack is sort of kind of brought into a world of technology. A lot of our devices nowadays utilizes RFID in order just to connect. But RFID is a form of wireless communication that's using radio waves to identify, access, and track those objects. A lot of times you may have certain terms that are brought up when you're mentioning RFID, things such as tags or endpoints. Those are there to identify those items. You may also associate things such as readers or the connectivity devices. Those are devices that communicate with and gather data from those endpoints, those tags themselves, as long as within a certain range, and it's there to deliver data to the OS and then those devices themselves. And then you have the software, or if it's something implanted from the manufacturer, it would be a firmware or application. The software connects those RFID systems to those environments and collects and transforms the data from the tags or the endpoints and delivers that information to a network, an enterprise level, or consumer applications. NFC, Near Field Communications, is something we'll also mention here shortly that takes advantage of RFID, but these types of attacks with RFID a lot of times will be associated with things we've already mentioned. Things that introduce man in the middle, or you may say the acronym MITM, is there to provide intel or gather intel, eavesdropping. It may also be utilized to introduce replay attacks. That, in essence, could in turn create a denial of service. And then you also have the possibilities of cloning or spoofing, taking over the identity of those wireless devices using RFID. So some of the mitigation tips here is use strong encryption and authentication methods. Chip coatings. A lot of times you may have this as kind of introduced to new technology. It's not always going to be applicable. Use those devices within secure locations. Know your surroundings. Utilize software or middleware for any other additional protection layers. And NFC, like I mentioned before, near-field communications is there that's part of this whole RFID system or technology. It's using radio waves to identify those devices. NFC and RFID both operate at that 13.56 megahertz frequency. But NFC a lot of times is found in lots of locations, your wireless devices, your phones, credit cards, smart cards, but it's there to offer a secure form of data exchange. In that essence, that the NFC is basically the reader and the tag or the endpoint. And there's also other protection methods that you can provide for these NFC types of communications. A lot of times the attack methods are going to be some of the same also, such as eavesdropping or gathering intel, modifying the data, the attacker creating themselves as a man in the middle, introducing relay attacks, and spoofing. Once again, they can do this by the insecure form of data exchange or getting access to devices. In the last wireless attack we will look at here is something that's called disassociation, or, as I mentioned from the beginning, they may also refer to this as deauthentication. It is a part or an end result of a denial of service attack. The disassociation is going to be sending disassociated packets to these wireless devices, the clients themselves, associated with an access point. A lot of times it'll take advantage of maybe insecure or weak encryption, capturing the WPA, especially with a pre-shared key, or even a WPA2 handshake. It's basically there to force the clients to re-authenticate, or it's going to gather those physical address associations with the IP, an ARP request. A lot of times the disassociation attacks will utilize these command line tools, which could also be part of a GUI-based things such as AirCrack, Air Replay, and AeroDump. These specific types of commands can be generated from a CLI or a GUI base to try to connect to a Wi-Fi network, then try to capture those 802.11 packets or frames, and then start injecting those requests, address resolution protocol requests to those packets with those devices in that wireless network. It could be there to generate more traffic or try to take over and try to glean information about those devices. In those cases, the clients are going to be disconnected and not be allowed to connect until the attacker is done maybe manipulating that data or sending more traffic. Once again, that sending more traffic could be there part of the denial service, and it's not getting access to the other clients.